All right, welcome to the second half of my video on Pythagorean Theorem and the converse of the Pythagorean Theorem. Converse of the Pythagorean Theorem tells us that if we have three sides of a triangle, we can check them. We can basically plug them in to our Pythagorean Theorem and test to see whether or not we have a right triangle. If you give me three numbers, A, B, and C, and they satisfy this, they create a true equation where a squared plus b squared equals c squared, then I know those three sides create a specific type of a triangle. It's got to be a right triangle. That's basically our converse of Pythagorean theorem. From that, we can look at Pythagorean inequality theorems. What if we plug in those three values for the lengths of the sides of our triangle, and we find that c squared does not equal a squared plus b squared. In fact, c squared is less than a squared plus b squared. Well, that tells us that this side c is too short to be the hypotenuse of a right triangle. And that means that this angle across from it must be too small to be a 90-degree angle. And therefore, that triangle is going to be acute. Or I could have this other condition where c squared is greater than a squared plus b squared. That means this side c is too long to be the hypotenuse of a right triangle. And therefore it's pushing this angle c past 90 degrees, which tells you it must be obtuse, and therefore it must be an obtuse triangle. Let's take a look at a couple of examples. Could we determine whether 9, 12, and 15 can be the measures of the sides of a triangle? If so, classify the triangle as acute, right, or obtuse, and justify your answer. Well, first of all, we should check and see, is this a triangle at all? You can pick three numbers out of the air and not necessarily make a triangle. From chapter 5, hopefully we remember that the two shortest sides must add up to more than the longest side. And in fact, here we can see that yes, we can make a triangle out of 9, 12, and 15. Now we can check to see which one of these it's going to be. We can plug in, if we call this A and B and C, as long as you recognize that if it's going to be a right triangle, we don't know whether it is or not, but if it's going to be, C will have to be the longest side. So we've got to plug that longest side in for C. So we get 9 squared plus 12 squared equals 15 squared. And we can crank this out. We get 81 plus 144, that's gross, equals 225, 15 squared. And 81 plus 144 is 225. So this does satisfy the Pythagorean theorem. Therefore, this is a right triangle. Let's try another one. 10, 11, and 13. First of all, can this be a triangle? Do the two shortest sides add up to more than the third side? Yes. So we've got a triangle. Now can we figure out what type of triangle it's going to be? Which of these numbers has to represent C in our Pythagorean theorem? This guy has got to represent C. He's the longest side. If there's a hypotenuse, it's going to have to be the longest side. So we can plug in 10 squared plus 11 squared equals 13 squared and see if we get a true equation. 10 squared is 100, 11 squared is 121, and 13 squared is 169. And you can see right away that we get 221 does not equal 169. In this particular case, don't forget, this is over here on this side, that's c squared, right? So is it safe to say that c squared is less than a squared plus b squared? And in that case, which of those conditions are we looking at? Where c squared is less than a squared plus b squared, that's our acute triangle. In other words, this guy is too short to be the hypotenuse of a right triangle. So he must be part of an acute triangle. Let's try another one. Here, could we determine whether this set of numbers, 7, 8, and 14, can be the measures of the sides of a triangle. 7 plus 8 is 15. So yes, we can make a triangle. It's greater than 14. And if this is going to be a right triangle, this would have to be C. So let's go ahead and see what we get. 14 squared equals 7 squared plus 8 squared. In this particular case, 14 squared is 196 equals 49 plus 64. And 49 plus 64 gives you 113. Those are not, in fact, equal. In this particular case, C squared is greater than A squared plus B squared. C is too long for this to be the hypotenuse of a right triangle. Therefore, this must be an obtuse triangle. Try one more quick example here. Here we've got 14, 18, and 33. Can they be the measures of the sides of a triangle? Let's check really quickly. 14 plus 18 is 32. Uh-oh, no triangle. Don't bother plugging these into the Pythagorean theorem because you don't have a triangle at all. So always make sure you first do that quick check. All right, I hope you enjoyed this lesson on Pythagorean theorem. Don't forget to like and subscribe if you're finding this helpful. And I will see you in the next lesson when we cover special right triangles.